In this final task, I'll incorporate the ranger districts into the analysis. So I'm going to use the Add Vector Data button and add that ranger district layer to the map. There are 3 ranger districts in the Sierra National Forest. I'll determine the ranger district that each spotted owl habitat polygon is situated in. To do this, I'll conduct a spatial join. Unlike an attribute join done in Lab4, a spatial join appends attributes from one layer to another based on location. Using this tool will allow me to attach the attributes from the ranger district layer onto each spotted owl habitat patch. Remember that data layers need to be in the same coordinate reference system when conducting geoprocessing operations between layers. So I want to check the spatial reference of this ranger district layer. Open up Layer Properties, go to the General tab. And remember, the other layers were in California Albers, EPSG code 3310. This is in a geographic coordinate system with an EPSG code of 4269, which is the datum of NAD 83. I'll close this. Since it's in a different coordinate reference system than the other data sets, I'll first have to save it to a new coordinate reference system. So I'm going to right-click on it and choose Save As. I'm going to click Browse, and I'm going to rename this Sierra Ranger District Albers, and click Save. And then I'm going to choose the CRS that I want the new layer to be in. So I'll click the Browse button to the right of CRS. And I'm just going to put in the EPSG code 3310 in the filter box to find that CRS. I'll select it and click OK. Then I'll click OK on the Save Vector Layer As button. So it reprojects the data. I can remove the original one. I no longer need that. And I'm going to spend a moment styling this layer. So I'll open up the Layer Properties, go to the Style tab, choose Simple Fill, and for the fill style, I'm going to choose No Brush. So I'll have just an outline for these ranger districts, and I'll give them a border color of dark green, and I'll make it a little thicker. Click OK. So now I can see the ranger districts in combination with the other layers on the map. Now I'm ready to conduct the spatial join. So from the Vector menu, I'll go to Data Management Tools, Join Attributes by Location. The target vector layer will be Sierra Spotted Owl, and the join vector layer will be my ranger district layer. I'll leave the default Take Attributes of First Located Feature setting, and I'll choose an output shapefile. I'll call this Sierra Spotted Owl Ranger District. With that set, I'll click OK. I get the message that it created the output shapefile. Would I like to add it to my Layers panel? I'll click Yes. And I'll click Close. So I'll turn off my original Sierra Spotted Owl layer, and now I have a new one. And now I'll use the Identify tool to query the individual polygons of this new Spotted Owl Ranger District shapefile to see that these additional Ranger District attribute columns were added. So I'm going to select my Spotted Owl data. I'll use the Identify tool, and I'll click on some of these polygons. And you'll see that there is a district name, the Base Lake Ranger District for this one. I'll click on one in this Ranger District and see that it is in the High Sierra Ranger District, and down here the 3rd Ranger District, Hume Lake Ranger District. So in this lab, you've explored the use of vector overlay tools with habitat data in the Sierra National Forest. There are many similar overlay tools which, when used in combination, allow you to parse the spatial relationships of multiple data layers. These tools allow you to extract data and turn it into information by narrowing down the area of interest. For example, you could now calculate the acreage of the overlap areas to determine that, and you could even determine how much habitat lies within each ranger district. This is indeed then information that you've derived from the GIS that can be used to make better decisions on managing these habitat areas.